Today we're going to talk about solving systems of linear equations using the substitution method. The substitution method eliminates one variable by plugging in the other variable. So in this case, we would be getting rid of one of our variables by substituting in, just like in sports, we substitute in players, we substitute in another variable. So let's take a look at an example and see what this means. The first thing that we're going to do when we look to solve a system of equations using substitution is we always look for, is one of the variables easier to solve for, or is it already solved for? In this case, in the second equation, y plus 2x equals 9, we can easily solve that equation for y. So we can rewrite it as y equals negative 2x plus 9. So now we have one equation where our variable y is by itself. We now have the equation, so if we rewrite these, we now have the equations 3y minus 2x equals 11 and y equals negative 2x plus 9. So now that we have them written that way, I can see that it's pretty easy for anywhere that I see a y in that first equation, I can replace it with the expression negative 2x plus 9. So I'm going to rewrite my equations having done that. So I'm going to put 3 parentheses negative 2x plus 9 minus 2x equals 11. So all I did was I took the first equation that I solved for y and plugged it in wherever I saw a y in that 3y minus 2x equals 11. So let's write some steps down. Step 1, solve one equation for y, or x. I always say to do the easier one, whichever one's easier. Step 2, plug new expression actually, in for the other variable. And step 3, after we do step 3, or when we do step 3 is exactly like we've always done when we've started solving equations. I now have an equation that I can distribute through that 3, so I get 3 times negative 2, I get negative 6x, and 3 times positive 9, I get plus 27, minus 2x equals 11. So step 3 is to solve as usual. So now, once we have distributed through, we can now start combining our like terms. So I get negative 8x plus 27 equals 11. We can subtract 27 from both sides. And when we do so, we get negative 8x equals negative 16. So x is equal to positive 2, remembering that a negative divided by a negative is a positive. Now there is a step 4 that we have to remember. Step 4, solve for other variable. So in this case, we solved for x originally, so we have to now solve for our y, because remember, when we have a system of equations, it's always going to be a coordinate. Now it's completely your choice which one you substitute back into. You can substitute back into this one, or you can substitute your x back into the second one. I personally think that the second one is going to be an easier one because we don't have to then solve for our y. So let's plug it back into that one. So we get y plus 2 times 2 equals 9. Y plus, well, 2 times 2 is 4 equals 9. So when we subtract 4 from both sides, we get y is equal to 5. Now, even though we've gotten answers for x and y, we have to check these. So let's check them in the other equation that we did not use. So 3y minus 2x equals 11. So 3 times 5 minus 2 times 2 equals 11. And we're going to put a little question mark because we don't know if that's true yet or not. So 3 times 5, that's 15, minus 4. Does that equal 11? Well, 11 equals 11, so we get a little check mark. So we know that this coordinate, 2, 5, is going to work. Now, you can always check using your calculator as well, as long as you're not asked to show your check. Here is a second example. Copy this one down and try it on your own. Once you've done that, restart the video, or if you get stuck, restart the video and you can see how the solution is worked out. Once we've written down the problem, we can see that personally, this one's going to be a little bit easier to solve than the other one. And we can solve for either variable. Let's solve for x. So we know that x is going to equal negative y plus 1, because we can subtract y from both sides. So into our second equation, we're going to say negative y plus 1 plus 3y is equal to 9. Okay, so now we are able to combine our like terms. So negative y plus 3y gives me 2y plus 1 equals 9. Subtract 1 from both sides, we get 2y is equal to 8, y is equal to 4. However, we are not finished. We still have to solve for our x. So let's do that. So now we're going to solve for x. So we're going to plug back into either equation. Let's do the easier one. X plus 4 equals 1. So x is going to equal negative 3. But now we still have to check to make sure that it works. So our check done algebraically. Negative 3 plus 3 times 4, does that equal 9? So negative 3 plus 12, still not sure if it equals 9, but yes, 9 is equal to 9. So the coordinate that we would write would be negative 3, 4. Let's try a third example. Again, now is a perfect time to pause your video and try this one on your own. Remember, you can always restart the video if you get stuck, or fast forward to make sure your answer is correct. And you can always double check using your graphing calculator. The difference between this equation or these two equations and the ones that we've seen so far is in this time we don't have x's and y's, we have a's and b's. That's okay, we treat them exactly as we would if our variables were x and y. In this pair of examples, or this pair of equations, I think that second equation, 2a minus b is equal to 0. So when I solve that one and I rewrite it, I know that 2a is going to equal a b. So anywhere that I see b, I can replace it with 2a. So I'll rewrite my equation. 5a minus 2 times 2a, is going to equal 3. So 5a minus 2 times 2, that gives me 4a, equals 3. And 5a minus 4a gives me just 1a left, or a. So a is equal to 3. But now we have to solve for b. And I'm going to plug it back into 2a minus b equals 0. So let's solve for b. So 2 times 3 minus b is going to equal 0. So 6 minus b equals 0. That means that 6 is going to have to equal b. But just remember, we always are supposed to check our work because we can make mistakes. It happens. We're human. So if I think the correct answer is 3, 6, I have to check. And I'm always going to check in the equation that I did not use. So 5 times 3 minus 2 times 6, does that equal 3? So 15 minus 12, and 3 does equal 3. So our coordinate 3, 6 works. So let's do a brief review. Our first step in solving using substitution is to get one of our equations solved for one variable, also known as isolate the variable. Our second step is to substitute back in, or plug back in, for the other variable, so we can get the equation in terms of one variable. Step 3, solve. Step 4, substitute in. From step 3 to get remaining variable. And then step 5, check and write as a coordinate. I hope this helps.